launching drones at high speeds to track enemies on the move, find pockets of hostile forces amid mountainous terrain, unload gunfire on enemy fighters, and support advancing infantry are all missions the Army's new Future Attack Reconnaissance Aircraft, FARA, are expected to perform. Senior Army leaders have been told that the new platform will bring a new dimension to forward reconnaissance, advanced networking, and drone strikes in the years to come. In recent years, the Army awarded Sikorsky, a Lockheed Martin company, and Bell development deals for the platform, which is intended to replace the now-retired Kiowa Warrior helicopter. Here comes Raider X! A FARA offering from Lockheed Sikorsky called Raider X could wind up emerging as the fastest helicopter ever to exist. The Raider X is intended to build upon breakthrough progress made earlier by Sikorsky with its X2 technology demonstrator, a high-speed coaxial rotor blade helicopter that set new records by flying more than 250 knots in 2010. Sikorsky's S-97 Raider helicopter in 2019 hit 207 knots. Sikorsky's FARA will expand upon and scale the S-97 Raider as it develops its Raider X prototype. The growth that Raider X builds into the X2 design to be able to increase the power, the large volume of weapons bays, which will increase the amount of armament, which will increase the situational awareness that these crews will have. Jay Macklin, Sikorsky's Director of Business Development for Future Long-Range Assault Aircraft, says it will truly provide unparalleled capability to ground maneuver commanders seeking to take on this very tough fight. What makes it unique? The Raider X builds upon and extends Sikorsky's highly successful coaxial counter-rotating rotor blades, which help the aircraft achieve breakthrough speeds while stabilizing flight trajectory and enabling a thrusting mechanism at the back of the aircraft. Since the balance of the two rotor blades moving in opposite directions stabilizes and straightens the flight path, there is not a need for a rear side rotor, a scenario that allows for a rear thrusting propeller. This rear thrusting propeller leverages aerodynamic wind flow to add thrust and forward propulsion, fortified by engine-generated torque or twisting power sent through a shaft to the rotor. There are few precise ways in which paradigm-shifting levels of attack and recon helicopter speed inform the tactical equation. A scout helicopter traveling at speeds faster than 220 knots is of course more survivable, meaning it could approach, surveil, and take off from a high-threat area potentially before being detected, or certainly be very hard to target. Advanced speeds, combined with a more fuel-efficient engine, can also greatly reshape combat radius dynamics. The initial requirements for the Future Vertical Lift, FVL, were to achieve a combat radius of 434 kilometers, roughly twice the distance of existing helicopters. That means missions can operate with a decreased need for forward air refueling positions, FARPs. In short, the new FARA will be able to conduct longer, faster, more lethal missions. Furthermore, when coupled with the kinds of next-generation, long-range sensors and targeting technologies now in development for FARA, scout helicopters can easily double as fast attack platforms. Then there is the question of stealth, as the fuselage does appear decidedly stealthy and less likely to generate a return radar signal in the way Apaches, Kiowas, or Black Hawks might get one. The shape is smooth and cylindrical with virtually no sharp edges, jagged contours, or protruding structures, more likely to give enemy radar a rendering based on a greater number of electromagnetic return pings. Multiple pings from different sharp or detectable shapes give radar commanders a much clearer picture of the dimensions of a given aircraft. Internally lodged weapons, of course, are a key element of stealth technology, to be sure. Available photos of the Raider X show a rounded exterior, raising the possibility that the helicopter operates with an internal weapons bay able to extend and retract weapons. A signature trait of the FARA will likely be its ability to operate drones from the cockpit in real time, building upon the successful operation of manned-unmanned teaming in recent years with the Army's Kiowa and Apache. Helicopter crews have been able to control the flight path and sensor payload from the cockpit to provide a considerable tactical advantage. For instance, Apache pilots have been able to identify enemy targets found by drones before even taking off for a mission. Murray likely had these tactical factors in mind when describing how Army plans for the FARA include the use of manned-unmanned teaming with an emerging new drone called Future Unmanned Aerial System. For example, in combat circumstances, FARA could, by itself or in tandem with forward-operating drones it controls, test heavily fortified enemy defenses, attack enemy targets, send back real-time video of enemy attack positions, and gather other sensitive combat intelligence information about terrain, navigational, or air threat challenges. Certainly, many attributes being designed into the Raider X are not likely to be available, given that requirements may still be in the process of being refined and adjusted with a mind to future technological approach. Command and control, targeting, and the analysis of sensor data are likely to be heavily shaped by emerging artificial intelligence, AI, and machine learning technology. As machine learning and AI-enabled computer systems become both more advanced and more available, helicopter flight crews will be able to command multiple drones at one time and rapidly access organized sensor data. Raider X and Apache together? Another key point is that, while the Raider X may reshape modern helicopter warfare, it will not replace the massively upgraded Apache attack helicopter, according to Murray. It might be a Big 5 1980s-era platform, but in recent years it has received a new, much more powerful 701D engine, composite rotor blades, new, more reinforced exterior coatings, longer-range advanced targeting sensors, and a focal plane array of small arms fire detection systems. Over the years, Apache helicopters have been engineered with various kinds of detection technologies. These technologies have been in the form of focal plane arrays searching for an infrared heat signature from small arms fire, and things like acoustic signatures designed to find the sound signature of incoming fire. There have even been light detecting sensor systems engineered to locate the muzzle flash coming from enemy weapons. One developmental acoustic system was called Ground Fire Acquisition System, and yet another was called Hostile Fire Detection System. Finally, as for being built for the future, the current E-model Advanced Apache helicopter is particularly built to accommodate new weapons applications as they emerge, such as a replacement for the Hellfire missile or new laser-guided rocket application. Thus, the Apache helicopters are expected to fly alongside the FARA for as many as several decades into the future. More to come! With its helicopter concept, Raider X, Sikorsky has been working to build upon these survivability innovations to bring new measures of combat power. Ed Fortunato, the vice president for Army Aviation Programs for Lockheed Sikorsky, told. The Raider X is built to withstand threats and detection by integrating a multitude of multispectral sensors to avert small arms fire, infrared threats, and mask the helicopter from radar. The X2 design provides a low acoustic signature that further enhances safety, along with transformational vertical maneuver and speed well beyond that capable of a legacy single-main rotor design. Raider X will not only fill the reconnaissance gap, it will provide capabilities that will take the Army through this century into the next.